Woohoo, we're live. Okay, this is Math 60, section 6.4. We're doing complex fractions, and we have just gotten to double complexity. And what's going on? Well, I showed you one technique for simplifying complex fractions, which is great until, dun dun dun, you have two terms. When you have two terms, what do you do if there's more than one term in the numerator or denominator? You have to use a new method. Okay, so this is going to be a new method. Now, I know some of you were taught how to do this. You just combine the fractions in the top or the bottom, and then you just do the flipping. If you already know a way to deal with these and you like it, then stick with it. There are many methods. If you have not learned a way to do this yet, I recommend this one. This one tends to be easier to learn. But again, if you already know one, if you have one that you like, there's no reason to switch over. You can use whichever one you like. But let me just show you how to do this one. It's going to be a little bit of work, but it's basically we're going to be clearing fractions, which since you've already learned about clearing fractions, this hopefully will be very natural. So look at all the fractions. I've got 1 over x, I've got x over 2, and I've got y over 2. What is the LCD of all of these? So let's look at the denominators. I've got an x and a 2 and a 2. And remember, since they're going to be wearing pants separately, we don't have to include both 2's. We just include one of the two. So I'm just going to include a 2 and an x. The LCD is 2x. Okay, next thing I want to remind you of. When I have a fraction, if I want to keep it the same value, if I want to keep an equivalent fraction, keep the balance in the fraction, I'm going to multiply top and bottom. What does this mean? Well, if I have 1 over x plus x over 2 all over y over 2, I'm allowed to multiply on top by 2x and on the bottom by 2x because I'm really multiplying by 2x over 2x, which is 1. I'm multiplying the whole fraction. Oops, sorry, you can't see that arrow. I'm multiplying the whole fraction by 1. Same thing over same thing. Okay, so this is what I'm going to do. Now, remember, when I've got two terms here and I'm going to multiply by something, I'm going to use the distributive property. So basically, I'm going to take the 2x, and just for the ease, and if this annoys you, then put it on the right. You don't have to put it on the left. But I realized what I really want to do is put them on the right. Let me get some. Oh my goodness. I don't know if you guys remember those beat poets, but they really have. They've absconded with all of my highlighters. Beat poets. Seriously, they're always stealing highlighters. You'd think they'd have plenty of their own highlighters, but no, they never do. They never remember to bring highlighters with them. Seriously, if you can avoid it, definitely try to avoid an invasion or an infestation of beat poets. It seems like a great idea at first. You're like, yay, free poetry. I feel cooler already. Suddenly there are more bongos in the house, but in the long run, they'll eat all of your granola. They steal your highlighters. They're snapping all the time, and the berets get into everything. Okay, so let's look here. I got a 2x over 1. 2x over 1, 2x over 1. So basically what I'm going to do is every single one of these terms gets a 2x over 1. It's balanced, it's equal. I'm not changing the value of the fraction. I am clearing the denominators. I'm clearing the fractions. Okay. So in this first one, the 2x and the x, you know what? I'm going to write it again so I've got room to play with it. I want to be able to cancel, so I'm just going to rewrite the whole thing again. That way in the notes, you can still read this step and it's not all ugly, because once I start canceling everything, just, it's just like scratch, 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 scratch. Okay, so this x cancels with that x. This 2 cancels with that 2. And this 2 cancels with that 2. So let's take a look at what we've got. I know I got to move this up. I've got 2 over 1 times 1 over 1 plus x over 1 times x over 1 all over x over 1 times y over 1, which equals 2 plus x squared all over xy. Now, this is, let me move the, there we go. This thing, this thing that I'm pointing to, the camera, that's it. I'm moving the camera so you'll be able to see more of the paper. In fact, I'm gonna open you up just a little bit. Okay, so what did we do? Basically, we took this fraction that has many terms, and we found a common denominator for all 3 fractions. We multiplied every fraction by this. That way, keeping the balance, we haven't changed the value of the fraction. This is totally legal. I'm not making stuff up. I know it seems like it's like, whoa, these new methods, this is kind of sketchy. Not sketchy at all. Real math, actual math. I am not giving you discount math. It's just cooler math, so you're not used to it. Cancel, 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 cancel. And then the magic happens that the denominators all get canceled down to 1. So you end up squishing the fraction. I'm not saying that this is a nice fraction. 2 plus x squared all over xy is nasty, but it is not complex. It is technically a simple fraction. Woohoo! So shall we do it again? Because we're only at 7 minutes. I know, right? Think of all the things we can do in 15 minutes. I can do 2 homework problems. We could eat some cereal. We could watch half of a sitcom. We could spend $400,000 on Amazon. Okay, so Tall Spider says, look, I'm so cute. Don't worry about how scary this is. Look, you can hardly even see the math. How scary can it be? But yes, it is true. We're going for the death problem now. That is a whole lot of death there, isn't it? Woohoo! Let me rewrite it, because you know how much I love rewriting the problems. 1 over a cubed b plus 1 over b all over 1 over a squared b squared minus 1 over b squared. There are 4 terms, 2 terms on top, 2 terms on the bottom. Again, if you know how to combine the fractions and flip it all and do the flippy thing, go for it. The rest of us are going to sit down. We're going to write out the fractions. All 4 of them. And I'm going to look for an LCD. So as I scan through, what's the most? Remember the most. That's what we're looking for. The most number of A's. And as I look through this one, the first one has the most A's. It's A cubed. Okay, let's look through. What's the most B's you see in any one of these? I think so. It's B squared. So A cubed B squared. So this is what I'm going to do. I know you can't see the problem, but you got to take my word for it. I'm going to write it down. I'm going to take A cubed B squared times each of those. Dun 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 dun. Oh, she saves it. There's the LCD. I'm multiplying it inside the fraction times each of the terms. Let me slide this. Oh, there's no sliding it down. You have to take my word for it. I have it times each of the terms in the original fraction. Let me see if I can make this. I can pull it out just a little bit. There we go. So you can see almost fits. Okay. 1 over a cubed b, that's there. Plus 1 over b, that's right there. 1 over a squared b squared, that's here. Well, you can't see my finger. It's right there. And then 1 minus 1 over b squared is right there. So we've got all the terms, and I just gave everybody their very own personal a cubed b squared. Okay, so shall we go ahead and cancel? Yes, let's cancel. And I am looking at this and realizing, you know what I'm going to do, because I love you guys so much. I'm going to rewrite it. So cancel Palooza will be over here to the side. And that way we won't have to sacrifice the really pretty one. This will stay pretty, and we'll do all the work over here. When you're doing your homework, you don't have, or tests, you don't have to write this twice. I'm writing this twice for the benefit of the people reading the notes, because if you write out the notes and then you immediately cancel everything, it all turns into, goulash. So in this first one, a cubed, b squared leaves a b. So in the first thing, all I've got is b. Over here, I'm just going to cancel a single b, so I'm going to cancel the b squared. Okay, down here, let me bring us down a little bit closer. Down here, I've got a squared, so that cancels with a cubed, but it leaves an a, and b squared. Okay, and then b squared cancels here with b squared. Okay, so let's combine like terms. Well, no, we're not going to do that yet. Let me just write out what we've got. Now, some people who are feeling lazy, and I totally understand that feeling, the feeling lazy feeling, it's a strong one, want to just write the a cubed b squared once and cancel everybody. And the thing to understand about this is different things. This cancels with this one almost completely, and it only leaves a b. This one cancels here only with a b and leaves almost everything. You can't just use one for the whole line. Each term, if you're going to do this method, you have to use a separate least common denominator or least common multiple for each term. Okay, you got to promise me that. Promise, please. Okay, good. If I'm going to trust you with this, and this is a pretty solemn sort of thing. Now, I've got good news and I've got bad news. The good news is it is now a simple fraction. The bad news is it looks to me like some stuff actually simplifies. So let's see if I can do this on this page. Let's see if I can get away with doing a single page. B plus a cubed b all over a minus a cubed. Okay, so let's come down here and let's see if we can. Okay, b plus a cubed b, there's a common b. Oh no, 1 plus a cubed. Our heart sinks because we know what that means. That's a sum of two cubes. Stupid cubes. Okay, let's go down the bottom. I got to factor out an a, 1 minus a squared. Oh no, 1 minus a squared is a difference of two squares. Okay, 1 plus a cubed is going to be 1 plus a. And then 1 squared minus 1 times a plus a squared. This, you're going to have to review your sum of two cubes formula. And then down here, 1 minus is 1 minus a, 1 plus a. And look, do you guys see what I see? Oh man, this is a sneaky one. Excuse me for being kind of excited, because anytime I can reduce fractions, I always think that I am like exploding them, and I don't feel like I owe fractions anything. I feel like if I can explode them, that's fine. Look at that, 1 plus a, 1 plus a. Okay, so I've got up here Those two cancel, cancel, cancel. If it helps, make explosion noises. Kaboom! Okay. 1 minus a plus a squared all over a times 1 minus a. Remember, I told you that when you've done a sum of cubes, this thing that you got left, the long one, it can't be, you can't break it up. So we don't have to worry about anything more canceling. Sneaky, sneaky. All that work, all this work, and then at the end, the answer still reduces. So there's our answer. You made it. That was the death problem. Congratulations. Woohoo. Okay, so we got a little bit more to do in this section, and then we'll go on to the next one. You guys are awesome and brilliant and very smart. Yay.